All right, let's look at this Unit 8 review. To simplify the square root of 180, I've broken it all the way down to its smallest parts. You could have had a couple of bigger parts than that, but a 2 and a 3 or a 6 come out. The loser 5 stays in. It's 6 square root 5. Number 2, we can multiply the numbers that are outside the radicals and the numbers that are inside the radicals. So 25 times 4 is 100. I'm going to choose not to make 6 times 15 90, but instead make 6 2 times 3 and 15 3 times 5, which of course is 90, but and go ahead and pull that 3 out. It's 100 times 3 is 300, 2 times 5 is 10, 300 square root 10. I'm going to offer you 3 ways to do number 3. The first way is to first reduce. First reduce. Now, I got a radical on the bottom. We can't leave it that way. You have to multiply by the square root of 3 over the square root of 3. Multiply straight across. Square root of 2 times square root of 3 is square root of 6. Square root of 3 times the square root of 3 is 3, and that is simplified. A popular way that is not better to do it is to multiply by the square root of 9 over the square root of 9. You get the square root of 54 over 9. Now you got to go do some work and simplify the square root of 54, which becomes 3 square root 6. Now the 3 and the 9 reduce, and you're again left with square root of 6 over 3. Or, hey everybody, what's the square root of 9? Yeah, that's right, it's 3. We could have gotten it just by taking the square root right off the top. All right, 5 square root 6 squared. We square the 5, and we square the square root of 6. The square root of 5 squared is 25. The square root of 6 squared is 6. 25 times 6 is 500. 20 divided by the square root of 5. Can't have the square root on the bottom, so I multiply by the square root of 5 over the square root of 5. I get 20 square root of 5 over 5. That reduces. 20 over 5 is 4. 4 square root 5 is the answer. What kind of triangle can you get from the given sides? Well, first of all, be careful. Make sure they're in the correct order. C here is my biggest side. That's the way people will get this one wrong. Can you make a triangle? First of all, well, do the two smaller sides added together. Are they bigger than the third side? In this case, yes. 10 times 24 is more than 25. So now I can go apply the Pythagorean theorem. 10 squared plus 24 squared. How does it compare to 25 squared? 676 is more than 625. The c squared is less than, so that's acute. Number 7, is 3 plus 7 more than 11? Nope, no triangle. Number 8, the square root of 3 is 1 point something. I typed that in my calculator. The square root of 7 is 2.6 something. I typed that in my calculator. The square root of 10 is 3.16 something. So is 1.7 plus 2.6 more than 3.16? Yes. So now we can go do the Pythagorean theorem. How does the square root of 3 squared plus the square root of 7 squared compare to the square root of 10 squared? Well, 3 plus 7 equals 10. That's a right triangle. Okay, number 9. I'm given 2 sides, need to find the third. That is a Pythagorean theorem question. A squared plus b squared equals c squared. In this case, 16 plus 49 equals x squared. That's 65. The square root of 65, that's 5 times 13. Nothing comes out of that. So square root of 65 is your answer. When you have right angle with a big right triangle and then a altitude right angle coming out here, otherwise we have, or another way to say it, we have 3 right triangles all in one. This is the geometric mean question. So the legs of the big triangle and the altitude, they are geometric means between the parts of the hypotenuse and the entire hypotenuse of the big one. So 5, 15, and 20. T shares a triangle with 5 and with 20. So T is the geometric mean between 5 and 20. T squared equals 100. T is 10. N shares a triangle, the triangle on the left with 5, and the triangle on the right with 15. It's the geometric mean between 5 and 15. Square root of 75 simplifies 5 square root 3. Number 11, these should be some right angles over here. That was mismarked. This is a rectangle / right triangle question. So that x comes over by virtue of being a rectangle. We need to figure out what this little piece of that triangle is. Well, remember this is a rectangle, so 13 and 13. What's left? 13 plus what is 17? That's 4. Now we will use the Pythagorean theorem to solve my little yellow triangle here. 4 squared plus x squared equals 8 squared. You get x squared is 48. The square root of 48 is 4 square root 3. Number 12. This is an isosceles triangle. How do I know it's an isosceles triangle? Well, because opposite those two congruent angles have to be two congruent sides. So if that one side over there is x, that is 2. 12 is an altitude, so it splits that in half. That's going to be, makes that 10, 5, and 5. So then now we use the Pythagorean theorem. 12, 5, and x. 5 squared plus 12 squared equals x squared. Go solve. If we were going to find the area, by the way, 10 would be my base, 12 would be my height. We've seen that question in that form as well. Number 13. I got two triangles. The one that involves x only have one side. I don't know the third. The other triangle, I know two, and I need I can find the third. So I'm going to call that third side n. Buy one, get one free, Pythagorean theorem. 3 squared plus n squared equals 5 squared. Go solve. N is equal to 4. Now I can solve for x using the top triangle. 2 squared plus 4 squared equals x squared. You end up with 2 square root 5. We solve. Number 14, I know what two sides are. I need to know the third. Pythagorean theorem. X squared plus 5 squared is square root of 37 squared. Solve. X squared equals 12. X equals 2 square root 3. Here's one of those rectangle right triangle ones again. Make a rectangle. That 4 comes over. The 3 comes up, which splits that 6. That happens to be a midpoint. That's not often the case. Now I can go Pythagorean theorem. 3 squared plus 4 squared is equal to 5 squared. So x is 5. Number 16. Do you see that magic number there, 45? Therefore, we can say that x and y are both legs of this 45, 45, 90 right triangle. Square root of 6 is the hypotenuse. Because we're going from the bigger thing to the smaller thing, we will divide the square root of 6 by what number in a 45, 45, 90? Square root 2. So square root of 6 divided by the square root of 2 is the square root of 3, and because it's isosceles, both x and y are the same. Number 17, I see 60 degrees, 30, 60, 90 triangle. 22 is the hypotenuse, x is the short leg, y is the long leg. We always go to the short leg from whatever we're given if we're not given the short leg. The hypotenuse is the short leg, bigger to smaller, so I divide 22 by what number? Hypotenuse to short leg, 2. 22 divided by 2 is 11. Now that I have the short leg, I'll go from the shorter leg to the longer leg. That's multiplying. Smaller to bigger, multiply. By what number? Small leg to short leg is square root 3. 11 square root 3 is that. Now, number 18 is also a 30, 60, 90 triangle. This time it gives us the short leg. So to go from the short leg, for each of them, I will multiply 2 square root 6 times what? Short leg to hypotenuse. That's times 2. So the numbers that are not inside the radical multiply. I get 4 square root 6 for x. There's no blank for y, but yeah, we would want to solve for y in this case. To go from the short leg to the long leg, we multiply by the square root of 3. So the square root of 6 times the square root of 3 is the square root of 18. That simplifies. Square root of 18 is 2 times 3 times 3. A 3 comes out. Y is 6 square root 2. If the perimeter of a rhombus is 100, well, a rhombus is an equilateral quadrilateral, so all of those sides are congruent. That's 25, 25, 25, 25 all the way around. If one of the diagonals has length of 48, well, that splits that diagonal into two congruent parts, 24 and 24. There's a right angles in the middle, property of rhombus, so now I can go Pythagorean theorem to solve any one of those 4 right triangles. X squared plus 24 squared equals 25 squared. Go solve, solve, solve. X is 7. That's not the answer, because look right up in here, x and x. The answer is x plus x, 7 plus 7, 14. If the area of a square is 121, then one side of the square is 11. 11 times 11 is 121. If it's a square, then the diagonal is the hypotenuse of a 45, 45, 90 right triangle. So the diagonal length, I'm going to multiply by the square root of 2. The answer is 11 times the square root of 2. Complete the following. Don't solve. What is the sine of L? Well, before I go any further, I know that I've got 2 sides. Eventually I'm going to need all 3. You got to go figure out, if it only gives you 2 sides of a right triangle, go figure out the third. In this case, it's square root of 5. Sine is opposite over hypotenuse. The opposite of angle L is, that's wrong, hold on. There we go. The opposite of angle L is 2. The hypotenuse is 3, so it's 2 over 3, sine of L. The tangent of K, K is the opposite, square root of 5. I'm sorry, well, tangent is opposite, square root of 5, over adjacent 2, square root of 5 over 2. The tangent of L, that's the opposite 2 over the adjacent square root of 5, but you got to simplify. You can't leave a radical in the denominator. Go fix that. We end up with 2 square root of 5 over 5. All right, home stretch. When the question involves one side is given or two sides are given and there's an angle, all of these involve either one side or two sides given plus an angle. When it's an angle side and side, don't get that confused. It's like side and a side. Anyway, when we're trying to solve for a variable using a side, an angle, and a side, sine, cosine, and tangent is what we use. From the perspective of 71 degrees, x is adjacent, 26 is hypotenuse. That's the cosine. The cosine of the angle, 71 degrees, equals x over 21. To get x alone, x times 1 is x. I will cross multiply. From there I get the answer, 8.46. Number 23, from the perspective of 41, 28 is opposite, x is hypotenuse, so that's sine, opposite hypotenuse. The sine of 41 equals 21 over x. In this case, I want to switch the extremes so that I get x over 1, which is x, equals 28 divided by the sine of 41. That's 42.68. From the perspective of my angle x, 12 is opposite, 16 is adjacent, so that's tangent. The tangent of the angle equals 12 over 16. Because I'm solving for the angle, whenever the angle is inside the sine, cosine, or tangent, or you're solving for the angle, that's just when you use arc sine or arc cosine. In this case, arc tangent of 12 over 16. Number 25. Actually, on all of these, if you think about it, you could have found the other angle. This question is no different than this. We could have figured out that this angle right here was 49 degrees, or that this angle right here was 19 degrees. All of that was fine and good. So, it doesn't matter which angle you use. If I say the tangent of 23, that's x over 36. If I say the tangent of 68, that's 36 over x. Solve either one of those. And same thing for solving for y. It doesn't matter if you use 23 or 67. From the perspective of 23, you'd use cosine. 36 is adjacent. From the perspective of 67, 36 is opposite. So it's 36 over y either way. That's how you solve for those. Hope that's helpful. Talk to you soon.